Whew. All right, do we have everybody here? Oh my goodness. All right, who has the AC in your room? Who has the AC running? Nobody? My goodness. So you guys not using AC at all in this hot weather? Whew. Or maybe you just don't want to answer the question. You know I'm gonna heading over to your house and use the AC there. Oh boy. Now, how hot it is in South Cal? Anyone? Who is from South Cal here? San Diego area? Oh, I missed my paper here. Kevin said 80. Oh, are you sure? I thought it's a triple digit here in Bay Area. I imagine LA could be even hotter, right? Emily, what's your temperature there? Don't know?
It's 90.
San Marino 97. Oh, Fremont 91. Okay, that's not too bad. What else? Cupertino 93. Irvine 84. Okay, I stand corrected. Wow. Okay, we're still missing somebody. All right, now everybody finished the task pretty good, right? Got enough time to finish everything? Sorry for the confusion, but we did salvage 2 problems inside of 3. So hopefully that would have cut down the time a little bit. So today we're going to be moving on to chapter 27. Did anyone take a look at the PPT? Anyone? I need to use a fan or something. Oh boy. Okay, so according to our syllabus, let's see. We're supposed to wrap it up 27, 29, 30, and 31. So according to the current schedule, we have 1 more class on Tuesday, and then that's not going to get it done in 1, 2, 3, 4 chapters. So 27. Okay. So maybe what we can do, let me think, what's the best way to do this? Maybe we can finish 27 and at least do a chapter test on 27 and use the finals for 29, 30, and 31. Okay. So again, pending on your school schedule, that's going to be, I know a lot of the schools going to be opened up next week. So some of you even this week, probably, right? So, and our class manager is reminding everybody on Tuesday. Okay. Cool. Okay, any questions on that? Maybe what we're gonna do is not having the final right away. give you a little time to going over the material first. And then let's see. Maybe we can do the final on the 23rd. And that's 22nd. Yeah, next Saturday would be 22nd. Yeah. Yeah. And we're gonna use the finals probably just like a chapter test. Okay, so it's not gonna be weighted as before. Because according to the syllabus, you got a chapter test, so it's 40%, and then the final is 20%. So we have, if I remember correctly, we have 5 tests so far. Is that right? You guys remember that? I know for the second half, we have 2 tests already. Correct? Yes? No? Don't remember? Because we just took the second test last week, last class, right? So that should be the second test that we had, and then we're gonna have another one. So that's gonna give us 6 tests. The final supposed to be half, that's gonna be weighted as, originally it's gonna weighted as a 3 tests. So yeah, we'll see how we're gonna weight this. Maybe I'm thinking, you know, since we're gonna do the 29, 30, and 31, we would treat the finals at the same way as one of the tests. So that would give you an option, either keep all the chapter tests, because that's, you can redo on chapter tests. So that would give you a chance to, you know, if you do well on the finals, that's great, keep it. If you don't do that well, you can, you know, basically drop one of the tests, drop the final, and use the chapter test as your grades. So, yeah. Or you can retake the chapter test on 29, 30, and 31. I think last one, everybody did pretty good, so there's probably no need for retake. So take a look and see what your score is, and you can decide whether you're gonna keep the last finals or, you know, use one of the, hold up. I have, oh, okay. So you guys already been told that anything that's not covered, we can use Lex February to make it up. Is that what you guys been told? No? Yes? Don't remember? Oh, I thought Dr. Yu told you guys already. Well, our class manager just reminded me that through the text, saying that anything that's not being able to cover it, then we do that on Lex February. Huh. Okay. All right, Leona, can you hear me?
Yes.
Okay, when did that happen? Is that Dr. Yu told everybody that before?
Yes, in the staff meeting, and actually he sent out an email remind on the instructor and class manager that if there's anything that we can cover during the summertime, so there will be on the February 2021 because we have a test, AP test prep class.
Okay. Now, the question is, are all the students supposed to have the grades for this?
Yes.
Right. So are we going to be just graded just based upon whatever we have learned so far?
I think so.
Okay, so that actually make your life a little bit easier. So maybe this is what we can do. Um, let's wrap it up 27 today, and then on Tuesday we're going to do the test on 24, 25, 26, and 27. Oh, actually, we already did 24, right? So we don't need to worry about 24. So just 25, 26, and 27. So that's going to wrap up the 6 chapter tests that we're going to have. So instead of going for a final on Tuesday, we're going to just focusing on 25, 26, and 27, the 3 chapters. That's supposed to be 40% of the grades. And then whatever that is, we're going to add half of the points as the 20% of your final. And that would be your semester grades. Is everybody clear on what the grading rubric is going to be? And we can still do the same thing. You know, even though it's a chapter test coming up Tuesday, that one is still going to be available for retake. So instead of giving you another final, we just take a look how everybody, you can even do your own calculation. Everybody knows your score so far, right? All the tests, correct? Does that make sense? You should have 5 of them right now. So with another one coming up on Tuesday, that would be the total 6 tests that you're going to have. So what you're going to do is whatever you got, the total 6, half of that is going to be counted as your final grades. And if that score is going to be good enough to get, I believe it's what, 90% or above, right? That was the rubric. That was the grading rubric, right? Yeah, 90% or above, that's an A. 80 to 89, that's a B. And also with the option of retake, that means one of the chapter tests, depending on what your score is, you can do a retake. Okay, everybody clear on that? Yes? Any question? Okay, all right. Again, right? I see some puzzle looks on some of you. If you have any questions, you can either ask now or you can text me in private. You know, that's up to you. All right. Okay. Let's go back to our chapters now. Where did it go? I'm gonna dive in and share screen right away. So Okay, everybody, can everybody see this? Let me minimize this. Okay, so for chapter 27, we're going to be dealing with the interference of the light, and the wave nature of the light. So, hold on. Jeez. For the linear superposition of any particular live wavefront, right? When these two travel out of phase, and then a certain distance, you're going to meet at a certain point, you're going to have constructive and destructive. All right, and then the wavelengths, the relationship between them, now this is the distance by the wave, and then this is going to be the constant. So we can figure it out. The travel distance differ by any r integer of half wavelengths. All right, so we're going to go back to our textbook and take a closer look. And also, when you have this kind of double slit, and then you're going to figure it out, where is the so-called bright spot and where is the so-called dark spot. And also the angle is going to be related to M's dark fringe or bright fringe, depending on which one you're going to be using. All right. So it's by whatever the order, right? The M equal to all integers. You can't equal to 0 start it out and then propagate further down the road. And we can see the intensity of either the bright fringe or the dark fringe is going to be related to the constant as well. When it's small, the intensity is bigger. When the number gets big, it gets blurrier, meaning the intensity is going to decrease. And also, we're going to take a look at the thin film interference, and the Mickelson's chapter 4, chapter 5, yeah, and then the diffraction, resolving power. There are quite a few formulas that we need to be going through in details. Okay, let's go back to the beginning. Since it's a linear superposition, right? The linear superposition states that whatever the end result is going to be the sum of all the individual ones. So when we take a look and say, okay, you have two different waves coming in, right? One is here, one is there. And the end results is going to be the superposition of both these wave source, the source of this and the resulting in this one. Okay, so this is at a certain, say, a given point of P. Now, in general, we already know the wave travels in phase, right? It has its own phase. Now, this particular interface is going to be happening at that P point, and also it's going to be varied by any odd integer. Okay, so when this one for 2, this one is 1, as you can see, this one is always going to be m plus 1/2 of lambda. And you can see the example. Let's see. Example right here. Okay, so when is the constructive interference? When did that happen? And when does the destructive interference happen? So we have two different interference that's going to be occurring when we have two different sources. Okay, so constructive interference happens when the brightness is greater than any single wave alone. That's when we call constructive. So if you do have a screen at a certain point, you would see a brighter spot over there due to the summation of individual ones. And the destructive interference happens, that means there's going to be low brightness, right? So the dark interference, so I'll say the dark fringe, that's when it happens. And the constant that's going to be related to that is, if given, say, the first wave has this wavelength, and the second source has this wavelength, in general, what the larger distance minus the smaller one is going to be equal to this. And that's where the M constant is going to be, equal to, when M equal to 0, 1, 2, or 3, and so on and so forth, right? As we can see from the second example down there, you're going to have this kind of a bright fringe or a dark fringe. So that relates to whether it's going to be a constructive interference or a destructive interference. All right. So if we use Thomas Young's experiment, that particular experience, double slit, you can see for certain spot on the screen, we're going to have a bright, and then we're going to have dark, and then we're going to have a bright. It's going to be oscillating. Okay, so for any particular, for two different sources, when these two equal to each other, you just add it up. The sum is going to be this, right? When you have a dark one, that's when you get, say, one of them is going to be brighter than the other one. So the summation of that is going to be brighter than any of the individual one. Now, for the dark fringe, that means the brightness is going to be darker than either one of these. Okay, does that make sense? When we talk about dark ones, we know that's destructive, right? Therefore, it's intensity-wise not going to be as big as any of this. When we have a bright spot, we know it's constructive. Then we know that particular intensity is going to be brighter than any of this individual wave. And what is that related to? If we do have a screen, we're going to have the fringe, and it's going to be oscillating, either a bright one and dark one and bright one, so it goes on both sides. All right, and it shows the pattern as well. So right here we can't really tell, but what they wanted to show is that the middle ones, if we take a look at the brightness, whether it's positive, whether it's the constructive or the destructive ones, the intensity of the wave, the intensity of the light is going to be bigger than all the ones on the side. Okay. All right. And due to the different kind of constants, then we'll be able to figure out where is the dark fringe going to be, and where is going to be the bright fringe. Okay, and this formula is going to give us, for bright fringe, this is the formula that we're going to use. For the dark fringe, this is the formula that we're going to use. All right. So whatever the constant is going to be, that means it's going to be the second order of the bright fringe. Right here, when the m equal to 2, that means it's going to be a second order of dark fringe. All right. So that's how the angle of theta is going to be related to the lambda as well as the m constant. So obviously, given any of these values, right, theta, constant this, as well as lambda over d, lambda versus d, given any of this value, we should be able to figure it out. What is the other given value? All right. So triangle, right? We know this is a right triangle. Therefore, we can relate to, say, d sine theta equal to m times lambda. Okay. Any questions so far? All right, let's do an example. So, third order, right? Now, if you already know it's going to be the third order, you know m has to equal to 3, right? So given the length, given the distance between these two sources, we should be able to do a calculation of this, right? Given the order, as well as the constant this and that, we can figure out what is going to be the sine theta, right? So, for example, it's red light, right? This is the constant, and it's going to be separated by a distance of this, right? This two is given as such. Now the screen is located at a distance of this. Find the distance y on the screen where the central bright fringe and the third order bright fringe. So again, right, this is the formula that we're going to use. And no, right here, the bright fringe, right? So this is a formula that we should use. So apply here, sine theta is equal to m times lambda over d. Now, what is m? Well, we need to figure out the third order, right? So it has to equal to 3. And what is lambda? Well, it's given as such. We're talking about the red line. And what is d? Well, we also given d as well, right? So if we apply it in here, we should be able to figure out what is that particular angle theta going to be if we wanted to find out the third bright fringe. All right. Okay. So, and also, once we know the angle here, right, we can use the tangent to figure out what is the distance, right? That's the final answer going to be, right? What is the distance between the central bright and the third order of bright? Therefore, by figuring out what is the angle here, then we can say, well, that is equal to tangent theta equal to y over L. Right? Everybody comfortable with that, right? And then if we already know what is going to be the L and what is going to be the tangent theta, we should be able to figure out what are the distance between them. Okay, questions on this one? All right. So again, we wanted to make sure that we understand when we talk about the bright fringe or the dark fringe, the formula is a little bit off, right? You need to plus 1/2, off by 1/2. Therefore, the same problem can be given as such. Say, what is the first order of the dark fringe versus the third order of dark fringe, and how you're going to figure out the distance between them, right? So we can also do that by applying sine theta formula, given these two constant, right? The distance-wise, distance between this, as well as the distance between the screen, we should be able to figure out what is this particular angle. And then we can say, all right, if that's the case, then how are we going to find out, you know, the order between here and then the dark fringe, okay? Oh. Now, do we have, let's see. Chapter 27. Before we move on to the theme film, let's go back and do, I know we have some sample questions that we can work on. One and two. Okay, easy enough, right? Let's make sure, let's give it a try. Excuse me. Let's give it a try on problem 1 and 2 on page A63. Okay, turn to your page A63, problem 1 and 2 for the first two sections. Okay, you guys go ahead and do your problem. My computer is making some kind of weird noise. I need to turn it off and then turn back on again. It's probably overheated. You guys can text me when you are done, right? Should be pretty fast. Whew. Hmm. All right, you guys done yet? Everybody? All right, let's take a look. Again, this is probably concept related more than anything else. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jessica, you are lucky number 10. First one?
E.
Okay, what's the reason for that?
So like the difference in the two like path lanes is like 2.5 lambda. So it's just 5/2 lambda.
Okay, so basically it's always kind of off by what? Half of a wavelength, right? That's the definition of the destructive interference. Now, what happens when they have the same phase? Anyone? Then when you figure out the difference, if they started out in phase, the constructive wavelengths will happen, right? When they're off by half of a wavelength, the destructive is going to happen. So in this case, what do we have? We're talking about the intensive minimum, right? Therefore, the distance is going to be, difference is always going to be half of lambda, right? Now the second one is going to happen when 3/2 lambda. And then the third one is going to happen when the difference is 5/2 lambda, right? So E is correct. Okay, let's see, who is, oh boy, my computer is making some kind of strange noise here. Don't know what's going on. Next one is Kevin. Kevin, number 2. Kevin? What you got for number 2, Kevin? Hmm? What do you think?
Um,
What's given? Hmm? What's the problem tell you? What's the given information?
so basic sine theta is approximately equal to theta.
Okay.
Theta is small.
Right.
And then lambda is doubled.
Okay,
And then d is also doubled.
right. And then what do you need to solve?
I think it doesn't change.
Angle doesn't change. Okay, why?
Because sine theta is equal to m lambda divided by d.
Correct. And it's already given sine theta equal to theta, right?
Yes.
So you can rewrite theta equal to m times lambda divided by d, right?
Yep.
If both of them are double, what does that do?
It cancels out.
They get canceled out, right? You got a 2 on top and 2 on the bottom, and it doesn't do anything. Therefore, the angle is not going to change, right?
Yep.
Okay. Everybody else agree with that? Okay. So basically, we just need to know the angle theta is going to specify whatever that particular m is going to be, right? The sine theta equal to m times lambda over d. Therefore, if you wanted to calculate the first bright fringe or the 50th bright fringe, you just need to plug in whatever the m is, right? So in this case, if it's already given sine theta equal to theta, we can say theta equal to whatever the m times lambda over d is. And then if you double the denominator and numerator at the same time, it doesn't change the theta at all, right? So, okay, all right. Let's take a 10-minute break, and we come back and work on the rest of the 27. Okay. Okay, let's come back on this. Everybody, make sure you turn on your camera. Let's make sure we cover the last few ones. My computer is somehow acting up and making some strange noise. Probably the fan, probably too hot. Let's see. Okay, so the first three covers up to the thin film interference. The last several sections deals with the diffraction and also resolving power and also the diffraction grading. So these are the few formulas. If you can turn your page A62, we have 3 additional formula that we need to be aware. And I'm gonna assign these as readings. You guys can definitely take a look. Now for the thin film interference, just making sure we have 2 different medium that we're talking about. If we know whatever the wavelength is the one that's given in vacuum, and then N will be the index of refraction of that particular film. So let's just say the light travels through a material with a smaller index. And then what happens is we're going to have a phase change that's going to be equivalent to 1/2 of a wavelength for that particular film. Now, if that light travels in a larger index of the refraction into a material that's smaller with a smaller index, then there's no phase change is going to happen, right? So whatever the lambda film is equal to the lambda in vacuum over n. Now that n is going to be the index of refraction of that particular film. Okay, and then when we deal with the diffraction formula, it's equal to sine theta equal to m times lambda over w. Now, in this case, the w is what? The width of the slit. Okay. Further down, when we deal with the resolving power, we're going to have that theta minimum angle is going to be in radians, equal to 1.22 times lambda over d. D would be the circular diameter. Okay. So, and also the diffraction gradient sine theta is equal to m times lambda over d as well. D would be the separation of the 2 adjacent slits. So the later chapters, later sections is going to be heavily used. This couple of formulas is going to be heavily used. All right. So that's where we're going to do. I suggest do the reading on the textbook. Probably has a little bit more explanation than the PPT that we have. Okay. All right. So let's make sure we have this done. The homework problem for this chapter . Okay, everybody see that? All right, so if you guys handle the homework, should be able to handle the chapter test. And we're gonna do that on, let's see, on Tuesday. All right, so that's gonna be chapter 20, 25, 26, and 27. All right. Question? Now, do we still have that TA help session going on Sunday? Anyone attended? No? Is it too early? 10 o'clock? Okay, so if there's a need, I believe that TA is still gonna be there. But in the meantime, if you guys got any questions, you can still shoot me an email, right, before Tuesday. All right? Okay, I guess I will see you guys on Tuesday. All right, we're gonna have this chapter test on 5, 6, and 25, 26, and 27. Already? Okay, you guys can have the rest of the day off, but make sure you do the reading, do the homework, and get ready for their chapter test on Tuesday. Okay? All right, I see you guys.
Mr. Wei.
Yes,
Oh, is Tuesday the last class, or is there more after?
say again.
Tuesday the last class, or are there more classes after?
There will be more classes probably coming up in February.
Okay.
Yeah, but I will make sure the material is going to be available for you guys if you wanted to read it ahead.
And will the final be in February too?
No, the material is going to be ready now if you want it. So we don't have to wait until February. So,
No, the final. Will there be a final?
okay.
Sorry.
We're going to have this chapter test, right?
Yeah.
So that means you're going to have 6 tests after that, right?
Yeah.
And the final is supposed to weigh 20%, half of the 6 chapter tests. So after the chapter test, you can use whatever the ones that you have so far, and half of the points, that would be your final grades as well. Does that make sense?
So I like take 3 tests, and those are my final.
No,
Well-
we're going to have another test coming up on Tuesday. That's going to be focusing on 5, 6, and 25, 26, and 27.
Yeah.
Right, like I already explained earlier portion in class. Therefore, once you have that 6 tests already, you should have a good idea what is half of the points going to be. That's going to be your finals. Now the caveat is you can redo chapter tests, right? So for any particular test that you deem you wanted to redo, you can still do that.
Okay. Thank you.
So once your chapter test grades are set, half of that is going to be your finals grades as well, in terms of the percentage. Does that make sense?
Yeah.
So at least this way, we don't lose the percentage, or we lose the grades, even though the material, the rest of the, like say, chapter 29, 30, and 31 would be covered later on at a later time. Let's just say February.
Okay. Thank you.
Okay. Yeah. All right. I'll see you guys Tuesday.